So the title of the talk today is Delivering Result-Driven AI Research. And it's going to be a series of lessons learned from the field, from experiences I had for the past year and 7 months at Element AI. A little bit about myself, just a bit to introduce myself and my background, and then also a bit about Element AI. So I'm the global lead for FS. So my name is Walid, and I'm heading the AI solutions and products for financial services at Element AI. So you can find more detail about my background on my LinkedIn. But aside from the products and solutions that I help our enterprises with, I focus on finding ways to help them commercialize their data through AI. And when I say by commercialization, meaning like finding a unique way where this data can play a competitive advantage in their business. And as part of my work, I work very closely with the product managers, data scientists, researchers, machine and data engineers. Now, Element AI is a global AI product company. We build a solution and software that is underpinned by AI technology. Our story really started in the labs, and then throughout the 4 years that we've been here, we transitioned to building really good industry-focused solutions and products based on that research that we built in the lab. And if you can check out about the products, just go to the link below. Now, before I start and talk about the specific lessons from how to take a research and then turn it into something that create a competitive advantage or create results and outcome from AI research, I want to give you a bit of background around the why and where the idea of this topic came about. So when I joined Element AI, so I was an ex-management consultant, I quit my job, joined this AI startup. Element AI has spent a number of years creating unique research in the lab, right? And at the time when I joined, there was a lot of, the vision is to take all that research and then go take it to enterprises and then create value from that research in the context of enterprise. And then what I learned from that specific mission is that the research that was done in the context of academia and in the lab is very different from type of research that's been done in the context of a business. So we needed to adapt, and the talk that I'm going to walk you through is about the lesson learned that we learned from that experience. Now, in terms of the target audience, just to make sure that we frame this talk specifically to the audience. So this is going to speak really well to the data scientists, researchers that are working within the context of an enterprise, that are always seeking to create repeatable success from the AI project and the AI research project they're doing in that enterprise, as well as it can speak really well to the managers of the data scientists. Now, in terms of just the framing, and because I think there's a lot of questions that I always receive is that, well, why do enterprises need AI research? They can just go and then get AI models off the shelf, AWS and Azure, and then make it work. Well, if you look at the AI maturity spectrum, you can see that there is, and then this is a simplification of the actual AI maturity. There's actually 5 stages that really describe the journey that, or the maturity levels of the different enterprise. The active level mean that the businesses are very early in the AI journey. And in this case, they might not need AI research. They are experimenting with the models, and they can just go and then get models, AI capabilities that are publicly available. And in this case, they can create value from that. That's enough. What I'm talking today, the lessons that I'm going to be talking about is in the context of organizations that really at the transformational level. Those are the mature organizations that are, they either sitting on captive data, meaning data that is going to create a really unique competitive advantage, but they haven't yet unlocked it, or they're seeking a competitive advantage in the research from mainly doing research in feature engineering, or in getting this unique model that going to create that algorithmic superiority in terms of in the outcomes and the results they create in the market. So now let's start talking about the 5 things that 5+1 that I want you to take away from this talk. So the first one, when we talk about the path to value from AI in AI research, applied AI research, can only be achieved by continuously improving the odds. Okay. So what this really means, it means that what I notice is that the paradigms for running a non-AI projects versus an applied AI research is actually fundamentally different. When we talk about non-AI projects, it largely depends, or executing non-AI projects, it largely depends on the delivery excellence, on how well that project is executed. Usually it starts with a bunch of risks, and then as you go in and execute the project, these risks diminishes. And that's what the business is actually expect from any technology delivery. But when you look at the AI research, it actually follows a different paradigm. The AI research is about increasing your chances to create this outcome, this value from that research. And this means that you want to increase the number of experiments you are able to execute during the duration of that project. So this means that you need to be able to run as many experiments. You need to look into extending the number of different configurations. But also you need to look at different variations under different conditions. This also means that it's not necessarily enough to just extend the time that someone is on the project or extend the duration of the project. It means that sometimes you need to bring in other people from other researchers from other areas so that you can have that cross-pollination effect in your research. And that is a different paradigm when you're trying to explain that to the business stakeholder around how you need to deliver this project and how you can actually set for success for delivering applied AI research projects. The second point is planning and executing the research around your AI advantage. So businesses, large enterprises, are choosing to invest in AI research because they want to gain that unique competitive advantage. So other people call it this defensive mode based on your data, right? So, and this advantage based on, like, we looked at a number of those research, and then this advantage can come from 2 places. One is from the captive data, so, and also feature engineering, or it could come from algorithmic superiority. Algorithmic superiority means that it's either a model that is not publicly available, that is in a research paper domain that has not been yet applied in an industry, or a combination of different models put in a very unique architecture, whether it's a stack, daisy chain, whatever it is, that can create that algorithmic superiority. So you need to know before you start the research is that where is that superpower is going to come from? Because it's only when you know where it's going to come from, it could be also a combination of both, that you can start planning the right activities in that research. So let's talk about if your superpower is from feature engineering and from the captive data, then your focus needs to be on the data pipeline. Is you're going to spend a lot of time on data integrity, curation, feature engineering. You have to continuously then revisit the choices you're making about the data that you're excluding or you're including as you're testing the models. And then also you need a SME to decipher those business integrity rules and relationships in the data. Now, let's take the other side where the performance is going to come from the model. Then what you need to do is that you need to focus on surveying research papers. You need to focus on creating an experimentation framework and configure and deploy a leaderboard. You need to focus on ensembling, on creating this unique model architecture. So that's a different focus. And knowing that early on actually going to help structure and plan the research better. The third point, and this is very controversial with the data scientists. So it's about balancing the spirit of the research with the business-driven goals. Now, if you talk to data scientists, they're actually not willing to put in on paper the concrete goals and KPIs that want to achieve through the research. And then is well understood the reasons why. But when you talk to the business, there's always a tension with the business because the business always come into these projects with a concrete goals they want to achieve because they're tying it to some concrete business outcomes. And then also like looking at that AI started number of years ago, I think the business is no longer willing to cut like a blank check for the AI team to really do a lot of experimentation without a direct tie to business outcomes. But at the same time, you cannot put specific outcomes on paper because that's gonna prohibit the data scientists from that curiosity they need in order to really diverge in the type of research they need to do, and then think outside the box when they're addressing these problems. Start with a baseline of where the performance exists. Then you need to formulate a hypothesis of where you think the research need to be invested, need to be actually conducted. Then you need to look at the end story, what's going to look like, so that you can communicate it back to the business. And then use visualization as much as you can in order to visualize the outcome for the business. Also, we use Jupyter Notebooks as a way to create graphs that are then put in documents as a way, for example, to communicate back to the business about the outcomes and how we're progressing towards hitting those targets. And leaderboards is a great also way to present these outcomes and then also to create some sort of gamification of the experiments between the different data scientists within a team. Now, the reason why I say it's very important to agree on a set of objectives because those objectives have a direct impact on the architecture you choose for the models. So just an example for that is, let's say that you're doing a research and then the objective would be like you need to hit certain up and down with certain level of accuracy, and then you have banding, right? Knowing how to frame and how these actually gonna look like, gonna have a direct impact that have potentially different outcomes. Right? So you could have up and down separate from the banding, or you can have both combined, and then you can have both as an outcome. So you need to clarify that early on with the business. It's good reason to have those objectives laid out and clarified early on. Number 4, don't underestimate the effort in building the requisites scaffolding. Now, if you talk to the business about what they expect from a research, they expect that in terms of progress, they expected a linear function, right? But it's not the reality. The reality in AI research is actually like more taper down, then a bit up, and then taper down, and then a bit up. And the reason why, because there's a lot of background work that needs to do in terms of the requisite before getting into creating the model, ensembling, testing the data, etc. So an example of what I consider scaffolding is like the data pipeline. And that includes a number of things: data curation, integrity, ability to not mix up the data sets more. And then if you can also even take it even further to create mechanism to detect regime shifts in your data. And you can even take it even further and create a feature repository. The second one is a model pipeline that can help you manage your models, manage the versioning of those models. And the third is creating an experiment framework. Experiment frameworks, what it does is lets you plan, design, and then also farm out different experiments that are run with different configuration and let you increase your throughput of how many experiments you can run, and then automatically record all the results. And then this way you can have a view about what actually works, what doesn't work. Lesson 5. Ensemble or daisy chain / integrate the models as early as possible. So this is also something that is well debated, at least in my team. But I would like to propose it here for discussion. So the research now is becoming a lot more complex, and a lot in a number of times is going to require ensembling, daisy chaining the different models. And then a lot of times, typically, this is really left as a last step in the research. And this is where you surface hidden, unexpected interdependencies or results from that activity. What I'm suggesting, what we find actually useful is try to do it as early as possible, but this is not set in stone. So this is done because it's needed as part of the research activity, but do it early on so that it can surface those unhidden uncertainties and relationship between the different models. And the other point I also want to say, going back to why you need to have a clear articulation of the objectives, because the way you articulate those objectives, going back to the whole banding versus and up and down, it has a direct relationship to what you need to do with respect to whether you want to do ensembling or daisy chaining and other stacking, for example. And then you need to do it early on so that you can give the business a view of what this outcome is going to look like. Number 6, and this is the last point, is harmonize the craft between data scientists and engineers. What I found is, because I'm working with a multidisciplinary team, so you have data scientists, machine learning, data engineers, service designers, all working together in a team, I found it useful to harmonize the craft. And what I mean by craft is the tools, the way that they're coding, they're creating the models, they're coding, they're creating the pipelines, the way that they're documenting, what our tools are using for visualization, how they're tracking their code, what's the cadence in terms of their code submissions. And that is good to align on that and making sure that that between the data scientists and engineers are all agree on the same on the same craft. And the other point I want to add to that is always build for productions. Data scientists coming from academia, there's a bit of pushback. They come with a pushback to that idea. But I think what we learned from our experience is because business, as soon as there is going to be a value and an impact from this model, there is always an appetite to put it right into production. So why not build it for production from the beginning? That's it. Those are all the points I have today about how to create result-driven research, AI research.
Thank you very, very much, Walid. It's greatly appreciated for you taking the time to share your knowledge and insights. I know Element AI, as far as big AI companies in Canada go, I'm pretty sure like you guys have the #1 spot. I've connected with a few people there. Huge team. Yeah, here we go. We've got all the applause rolling in there. So yeah, really appreciate it. This is where you'd hear the thunderous applause from the audience, generally speaking. But it's a COVID clap for you today, Walid.
Oh, thank you. Thanks, everyone.
I got my hair cut today, and I went to shake the guy's hand, and then oh no, actually we're bumping elbows. So. We have a question. It looks like we've got Wilco. Wilco's been here a few times. He knows what's up. Appreciate you being involved again, Wilco. So question, what are the typical pitfalls organizations step into when putting models into production?
Yeah. Okay, so the biggest issue, so overall, just in terms of like state of affairs in the industry, if you look at it, it's only 1 in 10 organizations actually have put models, are good at putting models in production and creating value from those models. And then the biggest reason is really the first mile and the last mile. So what you're referring to is the last mile. And the biggest reason for the last mile is actually, first of all, I think this is for all kind of project going into production, is the integration. So that's one. But the second one is overfitting. And then another one is the user feedback and the training of the model from user reactions and responses. And then the other one I would say is a user acceptance, because they don't trust, it hasn't been validated or enough upfront work for the outcomes to be accepted by the user. So those are the reasons I can think of that are preventing many organizations is putting it. One other thing to add is in industries that are highly regulated, the biggest factor of all is not the model is not audited, and that's specific to deep learning, deep neural networks.
Thank you kindly. Thanks for that, Wilco and Walid. We have another question from Atul, I believe it is. Thanks, Atul. Always build for production. Does it not slow down initially the initial model build?
I love this.
How do you overcome it?
I love this. So initially, when you start, is that you need to agree on patterns, right? On patterns, things that, and then this is going to come with your data scientists working with machine learning engineers and data engineers. Those engineers need to be actually really good at transforming data science code into production type code, or at least production light code, right? And then what we did is we established a life cycle. Every week we push our code into we merge our code and we push it not into production, but we push it into at least into staging environment. And then the machine learning engineer, they start off by establishing those patterns, what the data science need to do or what should not do. And then they take their code and then they audit it, they review it, and then in some cases they refactor it, and then they improve on it before merging it and submitting it.
Thank you kindly. We have one more question from Tani. I wonder maybe if that's Tani from Loblaws, who I spoke to a couple of weeks ago. Tani's question is, how do you help organizations set realistic expectations for what data science research can do for them?
Yeah. It's tough. It's not easy. So the way you need to speak business language. You have to tie in a lot of the capabilities that you're creating to business goals and the benefits. And in a lot of cases, it needs to be either something that is hitting the top line revenue, cost savings, or managing risk. Those are the three things that they really care about.